Hi, my name is John. This is from Anton, Chapter 3, Section 2, which is called the derivative. Okay, it's from A New Horizon, which is for Ventura High School, um, Calculus BC. Okay, the section is called the derivative. If you look up the word derivative on Webster's Merriam Dictionary, it usually says derived from another source. So derivative actually means derived from original source. So the derivative, in this case, you will hear this word, I don't know, at least like 100,000 times this year, maybe. But anyways, so the derivative means just taking the derivative of a function, which is usually written this way, f prime of x, or dy dx, or you say d of x. Sometimes they write it this way as well. So it depends on how you write the derivative function. And what is the derivative? What basically happens is this. When you have something like this, when you have two, sorry about that, this should have been a little bit more accurate. Terrible line right there. When you have a line starting at x, and here's h right there, right? And so when you have the distance of h right over here, and this becomes x plus h. And at x, whatever this function is this f of x, right? At x plus h, this would be f of x plus h. And this is called the secant line because it goes through 2 points, right? By definition, the slope secant is equal to y2 minus y1 over x2 minus x1. y2 is this value right there. Is equal to f of x plus h minus f of x. Do you see how this is the change in your y direction? Divided by x plus h and then minus x. There it is right there. If you notice, keeping it a little bit, simplifying the denominator, you end up with f of x plus h in the numerator minus f of x divided by the x's cancel, you end up with just h. That's the secant slope. Okay. So how do you find the tangential slope? Well, what you do is as h approaches 0, so this is getting smaller and smaller and smaller, it's going towards this point right here. So here's another secant, another closer secant, and finally you end up with this one secant right over here. I'm going to mark this with highlighter. Yeah, let's use pink highlighter on this. So this would be like the slope tangent. Okay. And can you see that it's kind of like tangent to this graph as h goes towards 0? You're going towards a tangential slope. Okay. And that's what they mean by tangent. So the slope tangent is equal to, by definition, it's the limit as h goes towards 0, limit as h goes towards 0, right? Of f of x plus h minus f of x, y2 minus y1, all over the change in x, which is h right over there. That's your definition of the derivative. And you'll see this a lot at the very beginning, but you actually won't use this definition. This means is defined as. So that's the definition of a slope or tangential function. So let's actually start to do some problems on here. I want to start with example number 1, let's say, okay? So let's do example, sorry about that. Let me use this back page. This is on page 178. And change it just a little bit like that. Bring it down a little bit. Okay, so how do we do this? The function looks something like this. F of x is equal to x squared. I'm not going to use the same. Yeah, I'm going to use it. I'm going to use a different problem. X squared minus 1 instead of x squared plus 1. Okay. And so you're going to try to find the, what am I going to try to find? Okay, I'm going to try to find the tangential slope. So it looks something like this. X squared is y equals x squared is a parabola, right? Goes something like that. And then -1 brings it down 1 unit. Make sure you learn to graph these, okay? And so it's going to be -1 right over there. And you're going to add 2. X equals 1, let's say. So x equals 1, you go 1 squared minus 1. F of 1 is equal to 1 squared minus 1. There's your function. It's equal to, evaluating this, you end up with 0. Okay, so it's going to be 1 comma 0. There it is right there. And you're going to try to find the tangential slope for this. And that's what it looks like. It seems to be like a slope of 2. I'm not really quite sure. But let's check it out. Okay. Using the definition, f prime of x, by definition, is the limit as h approaches 0 of f of x plus h minus f of x all over h. I always like to write the formula out first. That way it kind of helps you to start. This is the hardest part right over here, which is finding f of x plus h. F of x plus h is equal to, looking at this formula, you're going to plug in x plus h wherever there's an x. We're going to substitute x plus in for here. It's going to be x plus h squared. See the value x is replaced by x plus h squared minus 1. That's f of x plus h. Minus f of x, which is, I'm going to put parentheses around that, x squared minus 1 all over h. And excuse me, so that's equal to limit as h approaches 0 of, I'm going to distribute this out. You have to distribute this out. This is where the algebra gets a little bit hairy. X squared plus 2xh plus h squared minus 1. I'm going to distribute the minus over here. You end up with minus x squared plus 1 all over h so far. So don't forget to distribute that x minus 1. Minus x squared plus 1. You will notice something. A lot of things will cancel here. X squared will cancel. Minus 1 and plus 1 will cancel. So you end up with limit as h approaches 0 of 2xh plus h squared all over h. And you will notice something else too. And the thing that you notice is the h has to cancel. If it doesn't cancel, then you're going to have some problems. So you cancel an h here and cancel an h here. That becomes h. You can't really see this very well, so I'm going to use blue. Okay, cancel the h here and h here. That becomes an h. So you end up with limit as h approaches 0 of 2x plus h. You could not put the h in for 0 here because it's division by 0. But as soon as you cancel here in this equation, you can insert 0 in for h now at this stage. You end up with 2x. So the slope tangent at x equals, we said x equals 1, right? So f prime, the slope, f prime is the slope, at 1 is 2 times 1, which is just 2. That's your slope. Remember what I said earlier, it seems like the slope was positive 2. And here it is right there. And that's your slope. If you want to find the equation of this line, you have to use point slope form, which is y minus y1 equals m times x minus x1. Make sure you understand this is called a point slope form. You plug in 1 comma 0, that's your x1, y1. Your x1 is 1, and your y1 is 0. Plugging it in, and your slope was 2, right? We got it here. Plug into here. Y minus 0 equals 2 times x minus 1. Get rid of that. You end up with y equals 2x minus 2. And that's your final answer. I'm going to do another one for you, which is a little bit more difficult. Let's see if you can work through the algebra on this, okay? This one's a little bit more difficult, so I'm gonna spend a little bit more time on the algebra. Remember that algebra is about 70% of your errors. So you have the function like this. F of x is equal to 1 over x. Graphically, 1 over x looks something like this, if you remember. And at x equals 1, I want to find the slope. I'm going to use blue because it seems to work a lot better. So there's your tangential slope. I'm trying to figure out where that is. F prime of x, by definition, is the limit as h approaches 0. That's not your secant slope, it's your tangential slope of f of x plus h minus f of x all over h. The function is 1 over x, so f of x plus h, we just substitute x plus h, and for your x right over there, you end up with 1 over x plus h. Okay, so substituting that in, limit as h approaches 0 of 1 over x plus h minus f of x, which is located right over here, right? That's your original function, 1 over x all over h. Now, you got a problem right here because it's a really complex fraction, right? To get rid of a complex fraction to a simple fraction, you multiply top and bottom by the LCD. The LCD, least common denominator for these two, is x times x plus h. So what we're going to do is multiply the top by x times x plus h and the denominator by x times x plus h. What we're literally doing is we're multiplying this by 1. Okay, can you see that 1 right there? So let's see what happens when you multiply this by the first term. This multiplied by the first term right over here. I'm going to do this on the side. 1 over x plus h times x plus h all over 1. So this is the same thing as this right over here, over 1, right? So this portion happens to be the same thing here. You notice that the x plus h cancels. These factors cancel. You end up with just x. Look at the bottom. I'm sorry, the second term right over here. 1 over x times x times x plus h over 1. Notice that 1 over x cancels with the x in the numerator. So you end up with x plus h. So multiplying this by the first term, you end up with x minus, and then multiply this with the second denominator, you end up with x. You have to put parentheses around that, x plus h. And then all over. I'm going to keep the denominator factored, so it's going to be h times x plus h. H times x plus h. Just multiply straight with the h. Okay. What you'll notice is that minus right there. I'm going to use red pen. I'm going to use actually pink pen right here. The x's and this x will cancel. What do you have on the numerator? Minus h. Don't forget the negative right there. Okay. So what you end up with is limit as h approaches 0 as negative h over h times x plus h. Now, as you notice, what happens is now the h's will cancel. Remember I said the h has to cancel with the denominator. And you notice how it cancels with the numerator a little bit here. You end up with negative 1 over x times x plus h. Now you can substitute h equals 0 in here. So what's x plus 0 is just x, right? End with negative 1 over x times x, which is equal to negative 1 over x squared. If you remember from calculus AB, or if you've taken it, let's use the power rule, which is called the shortcut. Y is equal to 1 over x. Rewriting this, we can write y equals x to the minus 1 minus 1 tells me that it's in the denominator. So this is the same as this equation. The power rule says you bring this on down to the front, and then you subtract 1, right? So bring it on down first. Y prime, that's your derivative, negative 1 times x to the, subtract 1, negative 1, minus 1 is negative 2. I don't like this negative on the denominator, so numerator, so I'm going to put this on the denominator, which becomes y prime is equal to negative 1 over x squared. Oh, so you could have used a shortcut if you knew about the power rule, but we are currently using the definition of the derivative to find the actual derivative right over here. And a lot of algebra involved, so make sure you brush up on your algebra before, and you have to work through these. Good luck.